Alright, today we're going to talk about the natural logarithmic function, and we've mentioned this before. We actually spent a good bit of time on this in Calculus 1, so it should be somewhat of a review for us. So first of all, we'll just give you the definition of the natural logarithmic function. It's denoted by ln, and it's defined by here, ln of x is equal to the integral from 1 to x of 1 over t dt. The image over here is easy to see, so I just put a little bit of a sketch of the image so you can see that, and that's for every x greater than or equal to 0. Okay. Also want to remind you of this property here. So remember if we change these two here, then we pull a negative out front, so that just means the natural log of x is negative for the interval when 0 is less than x is less than 1, and it's going to be positive when x is greater than 1. So we've talked about this property before. Just want to make a special note of that. The next thing is our theorem is given to us that the derivative of the natural log of x is defined by is equal to 1 over x. Okay, it's continuous and increasing throughout its domain. Okay, if we were to take the second derivative of the natural log of x, it would be like taking the derivative of the natural log of x. Well, this is defined up here to be 1 over x. So then if I just rewrote this algebraically, moving my x to the top, so we take the derivative of x to the negative 1, you can see that we would get negative 1 over x squared. Okay, that's just to see if you take the second derivative. And then we talked about some theorems. So what if it's a little more complex and we have u substitution going on, or taking the derivative using u? Then if it's differentiable, then the derivative of the natural log of u is just going to be 1 over u, but we have to account for the derivative of u itself, and this is the case when x is greater than 0. And this is when we just have absolute value. If this is not positive, then this is when g of x is not equal to 0. So basically we got to do 1 over u, then we have to account for the derivative of that u. Okay, so that should be familiar to us as well. Also, we have our laws of natural logs, where if p is greater than 0 and q is greater than 0, then the natural log of p times q can be expressed as broken apart, expanded to be the natural log of p plus the natural log of q. Also, division can be rewritten using the subtraction property. So natural log of p divided by q is the natural log of p minus the natural log of q. And then we have our third property. If we have this p, it may be hard to see that, raised to the exponent of an r right there, raised to the r power. You can move the power out front, and it's just r natural log of p for every rational number r. So just reminding you about the theorems, the definitions, and the laws of natural logarithms. And the last thing we'll remind you about before we start some examples is going to be the guidelines for logarithmic differentiation. So when we get to these specific examples, it may help to come back to these steps to remind ourselves. So we'll be given a y equals f of x, then we're going to take the natural log of both sides, we'll differentiate implicitly, we'll use our theorem here to rewrite this, and then we'll multiply both sides by y equals f of x to solve. So these are just some steps to remind yourself. And the next thing we're going to do is we're just going to spend a lot of time working some examples. Okay, and our first example is y equals the natural log of 7x. So we're going to take the derivative, and that's going to be the derivative of the natural log of 7x is going to be 1 over 7x. But then we have to have the derivative of 7x. Okay, we'll write these out through most of these, but most of you are pretty quick about doing this. So I carry down my 1 over 7x. Now what is the derivative of 7x? Just 7, good. Now what happens here? This 7 will cancel with this 7, so y prime is just going to be 1 over x. Okay, very basic one. Let's look at another one. So what if y is equal to the natural log of t to the 5th power? works. Okay, so y prime is equal to, what's the natural log of t to the fifth? First of all, is just 1 over t to the fifth. And then we take the derivative of our u. So this is the u right there. Okay, we're bringing down 1 over t to the fifth. Now what is the derivative of t to the fifth power? 5t to the fourth. Good. And so if we put those over each other and simplify, what will we get? We're just going to get 5 on top and what in the bottom? Just a t in the bottom. Good. Okay, number 3. First thing I'm going to suggest is anytime we can rewrite, sometimes that makes it a little bit easier for us to work with derivatives. So let's rewrite our problem. Let's make the x a negative exponent. And now y prime is going to be 1 over 5x to the negative 1 times the derivative of 5x to the negative 1. Okay, so I'll just have this, carry this down, 5x to the negative 1. What is the derivative of this? Negative 5x, so let's see, we'll have negative 5x to the negative 2 power. Okay, so the 5's cancel, but I'll have a negative left on top. So first of all, I'll have a negative. And then what do you get when you subtract those? Negative 2 minus a negative 1. It's just going to be right. So we would just have 1 over x. And then I need to remember that negative that I had here. So a negative divided by a positive, negative 5 divided by a positive 5 is just a negative 1. And then negative 2 minus a negative 1 just gives us this. Okay, y equals the natural log of 2 theta plus 3. I'm going to pause it. You go ahead and attempt it, and then I'll just show you your answer. Okay, when you do the derivative here, make sure you do d theta since our variable is theta here. Okay, the 2 does not simplify because it doesn't simplify with both terms, so this just simplifies to be our derivative. Okay, let's do one with a trig function in it. So first of all, y prime is going to be 1 over cosine theta, and then we're going to do d theta of cosine theta. Okay, so y prime is equal to 1 over cosine theta. Now what is the derivative of our cosine theta? Negative sine theta. Good, so that's just negative sine theta. So this would simplify to y prime is equal to negative sine theta over cosine theta. And we could just stop right there, but if we did want to simplify further using trig functions, what could we say that is? Tangent theta. Good, negative tangent theta. Okay, so how many terms is in number 6? 2. So what's that mean we're going to need to do? Product rule. So I hope I have enough room for this. So y prime is just going to be first times the derivative of the second plus second times the derivative of the first. Okay, so that's just writing all the steps out. Now let's start calculating this. So I'll just carry down my x. Now here, what is the derivative of this term right here? We're going to use the chain rule, so we'll have 2 natural log of x to the what power? To the first power times the derivative of the inside function, right? So plus, now we're over here, I'm just going to bring that down. Natural log of x squared, and then what's the derivative of x? Just 1. Okay, now let's come through here and let's clean this up a bit. So y prime is equal to, bring down my x. Now inside of here, I'm going to have 2 natural log of x. Since that's to the first power, that's fine. What is the derivative of the natural log of x? This is what we're evaluating here. 1 over x. Good. Plus natural log of x squared is just going to be that. Okay, now here, what happens with this x times this x? They would cancel out, so we would just have y prime is equal to 2 natural log of x plus the natural log of x squared here. Now, if I wanted to take it one more step, because sometimes your textbook is real good about this, we could factor out a natural log of x, right? So if I took a natural log of x out of this term, what would we have left? A 2, and if we took 1 natural log of x out of this, we would have a natural log of x. Now, those are equivalent, but you know, if you don't see this answer in the back of your book, you may want to factor out a natural log.